Hey, hello everyone. You're live on YouTube as well, okay?
Hey, I'm trying to get my Fusion 360 loaded up. It's I might have to switch computers.
Okay. I'm going to make someone else the host. So who's going to be there? Evan, I'll make you the host.
Sure.
Okay. So you should be able to, even if I leave, you should be able to continue. Okay.
Okay, I'm gonna switch computers. I'll be right back.
How do I let people in from the waiting room, or is there even a waiting room?
No, I don't think there's a waiting room here.
Okay, so I don't have to worry about that.
Yeah.
Okay, hi everyone. Can everyone hear me?
Yes.
Yes.
Okay, thanks. I'm on Nishka's computer and she's on mine now. So I'm gonna start the presentation.
One second, let me leave and come back.
Okay. Let me know when you're here. And I can start. Evan, are you ready? Evan, are you ready? Oh, we left again. Evan, are we good?
Yeah.
Okay. Oh. So, hey guys, so this is going to be a Fusion 360 intro presentation. And in this presentation, I'm going to show you how to use Fusion 360 for two separate things. So firstly, we use Fusion 360 to construct virtual models. These models include those of our robot, which we can use to pre-plan for the season. We can also find the center of mass of our models to help us with robot balancing and moving straight with our actual robot. And then also finding if there are any space constraints so we can easily move around the components on our virtual robot so that that'll help us plan with our real robot. And then secondly, the second use for Fusion 360 is to design parts for 3D printing. These parts include mounts, connectors, and just about anything that you need that you don't really have an actual part that you can order from online from. So first, I'm going to start with CADing robots and tools, so modeling. So to create a new model, what you want to do is you first have to create a new file. It's kind of like any document you would have. You create a new file, but then to create your model, you have to use existing parts, such as you see these C channels on the left to make this go build a robot. All of these parts you have to import from individual files into a main file, and then you can eventually construct a robot that looks like this. Once you import your parts, like the battery, the C channels, the mechanism wheels, the motors, the gears, you can move around the parts to actually create the robot. And then if you actually want to modify the parts that you're using, like let's say you want to extend the C channel, that actually modifies the original file. When you modify a file that's your own file that you're using to make a robot, it actually affects the source file. So if you want to change the size of this or do something that actually affects this part, it will affect the source file and any derivations of that source file. So what you want to do is you want to break the link to that original part if you're going to be modifying. So to import your parts, all of you are added to this parts folder. And this is just in your, on the left side of Fusion 360, you can see. So to move parts, I'm going to show you how to first import it, and then we'll be able to move them. So you have to obviously use these, you have to get familiar with the software. So I'm just going to give you a demonstration of how we can first import and then move the parts. So I'm on this Fusion 360 file. So when you open Fusion 360, you get an untitled file, which you can use. And then we're going to import parts by going to design these the 3 squares up top. Or add initial. Oh, and then you have to click your name up here. And you should click absolute 0, and then all of the parts should be here. See, you make sure you're in absolute 0 though, because you have your own name and then absolute 0. So make sure you're there. Then you can go to parts. And then we have all of these categorized by their brand, like Tektronix, GoBuilda, Animark. So you can find these all pretty conveniently. And then you have your actual robot files. So I'm going to use this GoBuilda strafer as an example. And this whole file, the GoBuilda strafer, I imported from online from the GoBuilda website. So I didn't actually need to assemble this robot myself. But if we're building on top of that robot, then yes, we'll need to use the parts from this folder to import them in. And these bigger files take some time to load. So just wait a bit.
So are you just opening it or importing it into your project?
Right now I'm just opening it.
Okay, got it.
And then I'll try to import some parts. I'll continue with the presentation while this is loading. Okay, so I'm going to show you this again, but to verbalize it, you first have to click the move. You have to right click to get this menu, and then you click move/copy. And then all of your parts are either going to be bodies or components, which you'll get this list that pops up. They're not faces or sketch objects. So bodies or components are actual 3D objects that you'll use. So you need to make sure you're selecting one of these so that you can actually move your parts. And then you'll also, then under this menu, you'll get the parameters, how much you want to move it, X, Y, Z distance, and the angles. So you can either use that or you can use the arrows using your mouse. But this obviously is more accurate since you have exact measurements. So as I said before, if you're modifying a part directly, then you want to break the link so it doesn't affect the original file and any other source files. So what you do is you'll have this menu on the top left down here. And then as you can see, it has like a link icon. So to break the link, you have to just simply right click it and then it'll have another menu. And then you can just press break the link. And then this will make it so that you can edit this freely without affecting any other designs. Okay, I'm going to switch to the Fusion 360. Okay, so I have to go build a bot over here. And as you can see, it has a battery and then the base robot. So here you would see the link, if it was linked or not. So I can click this and this is the battery. And I can click this and this is the robot. So let's say I want to edit the battery.
Can everyone see that?
Oh, sorry.
Come on, everyone has to speak up. Are you doing something else? Well, is presenting or?
Can you see this? Okay. Yeah, so we have the go build a robot over here, and then we can select it using this this menu on the left. And then we have a battery that I imported earlier that we can find it's this component. And as you can see, both of these are directly linked to the source file. So let's say I want to modify this battery and make it taller for some reason. It's still linked, so if I edit it here, then it would affect the original file and any other files that have the battery in it. So I don't want to change any. I want to make sure that I don't change any other files. So I'm going to right click this and then break the link.
So let me give some additional comments on that. So typically you would not want to do this because what you want to do is you're representing something that's actually there, right? So you would typically use the existing components to create your robot. Now, let's say you have a custom component. Let's say you cut, a component to size. Then what you would want to do is in the part section, you would import that part, cut that section, create a new part, and then import it to your model. Okay. So typically that's how you would want to do this and not make that change here in the main robot. Okay, the main robot should have all parts that are linked to some part section that others can also use.
Yeah. So as you can see on the left, the link is broken. So that's how you know it worked. And then now let's say we want to move the battery. So I'm going to right click to get this radial menu, and then I can choose move/copy. So this is a drop-down menu that I told you about with the bodies and components. So now I can actually select the battery, and it'll since it's a body, it will allow me to just click that. And then if I want to move it to the center, let's say, then I can either use these arrows over here, or I can actually input the distances and the angles. So I can drag this, and then it shows you the X distance that you want to move. So let's say I want to move 90 millimeters. That's not exactly the center, but it's close. So and then I can press OK. And Fusion 360 is really slow today. So, okay. So back to the presentation. Now, the second part of using Fusion 360 is to design parts. So instead of importing already existing parts from like a file directory, you're actually creating your own. So we have to first open a new document, and then instead of importing the parts into the design, we're going to start with a sketch. And a sketch is just like a 2D, a drawing of what you want to make. And then using the sketch, you can bring it into a 3D model and then edit that 3D model. So I'm going to create a new file. Okay, I created a new file. And now the sketch option is in the top left corner. So you can create a sketch, and then you can select one of these faces. It doesn't really matter which one you do. And then this is where you start designing your actual part. So you can see that there are different shapes you can create using the sketch. Like you can use a circle, a spline, which is like a curved line, a straight line, and then you can make patterns and letters. So I'm going to start by creating a basic rectangle, and let's say I want to create a a book or something. So I can so I made this rectangle shape, and then to make it into a 3D shape, I stopped sketching, and instead I finish sketch, and then I have this face over here. Now this is a 2D face. I can't really do anything with it except extrude it. So extrude it means just make it 3D along the axis parallel to the face. So I highlight the face, right click, and then I can press extrude. And the shortcut is just to press E. And then as you can see, I have this arrow here, which I can use to pull either direction. And this makes it into a 3D object. So once I do that, if I can specify how much I want it. So let's say 120 millimeters. And then I press OK. So now I have this 3D shape, and I can edit it directly using more sketches. So now if I wanted to make it like a hole in the middle, I can create a sketch on one of the sides that I want a hole on, and then I can edit that side using these options. So I can create a circle, and if I think that's good, then I can finish the sketch and click the circle, and then I can extrude it. Now I can either extrude it outwards, which will extend the whole body, or I could extrude it inwards, which will cut the body. So if I extrude it all the way through, then it'll cut a hole all the way through. But if I want it halfway, I can also do it like that. Press OK so that I can see the hole ends in the middle, and it doesn't come all the way through. So that's just like something basic. You'll learn to use all of these tools up here. So one that you can use is, let's see, chamfer or fillet. So chamfer is here. So you can select one of the corners and then make it like triangular, so it's kind of smoothened out. You can also do it so it's round, which is called a fillet. So I can just move it like that. And now we have an angled face. So, and if I even wanted to, I could create a sketch on this face too, this angled one. So you can do pretty much whatever you want with Fusion 360 in terms of designing something. It's really like how much you know the tools for you to create what you want. So that's my object, and now I'll go back to the presentation. So some tips when using Fusion 360 to create designs is to sketch on paper what you want to make before you actually make it in Fusion 360. This will help you a lot with planning out, so you don't really have to. It's easier to draw than to actually use the software. So, and this can also help you with scaling, so that you use the exact measurements. See, like here, you can use graph paper and then write the measurements down. And then when you want to test like a part design, like so like parts of a design, such as screw holes or supports, you can test those individually. Like if you want to see if a screw will fit in a screw hole that's of a certain size, you don't have to print your whole object. You can just print a sample with that size screw hole and then test the screw in that hole instead of printing the whole thing and testing it. So this will just make like creating your parts for an actual 3D printed robot part much easier. And then also, like, going back to screw holes and other things too, you want to make sure that you have tolerances, which are pretty much you want to be sure that you're when you print something, the plastic usually expands. So if you have a screw or something that needs to fit in a hole, you want to make sure that screw actually fits. So you want to designate some space, some leeway space, so that your screw definitely fits inside the hole, even if the plastic expands. So this is just called a tolerance. And you want to use the same tolerances like all around. That's just kind of easy. Once you measure it once, you don't really need to do it again, because you know how much you need to designate for a certain type of plastic. And one thing we did like two seasons ago was shape optimization, which is kind of an extension to your parts design. And this is kind of using a simulation to get rid of the material that you don't necessarily need under the constraints that you put. So it kind of gives it your parts in an organic shape and eliminates all this material that you don't need on the inside while maintaining structural integrity. So that was the presentation. Does anyone have any questions?
So with this last part, it basically can take away unnecessary material, so it doesn't take as long to print, or it's not a waste of material.
Yeah, exactly. So we run it through a simulation, and we put in like, so our constraints are like, we want this hole to be like kept safe. We don't want the program to alter this hole, and we can also establish like a target density, which is how much of the original material we want cut away. And then you can choose not to actually use all of the suggestions that the simulation gives you. Like here, it suggests that you have this like thin beam in the it suggests that you keep this thin beam, but on the actual design you don't have to do that. You can just get rid of it, or you can even just fill this area up if you want to. Does anyone have any other questions?
I have another question. So I talked to one of the teachers at my school, and they said that that I would only be able to get my student ID on during picture day, and that's like October or something. So what would I do if I can't get an account using that?
I think you guys all got transcripts, but I'm not sure if they'll accept those, because I don't think they even have the school on them, do they? They do. Oh wait, no, they do have the school. Sorry, but they don't have the date, and so that's a problem. I think when you guys start school, I'll probably try to get you to like you can request for a letter that you from like a school official that you actually attend the school, and then they accept that for proof of like going to school. So we'll have to try that out.
Okay, that'll make sense.
That way you don't have to wait all the way until October.
Okay, thanks.
Does is that all? Does anyone want me to like show something more clearly, or any other tool or something with Fusion 360? Or go back to a slide?
So, wait, I have like a question.
Yeah.
So is there like a sort of a tool in like this is a tool in other CAD softwares? Is there a tool where you can like transfer the design into like, I don't know, a white sort of like white paper from CAD?
Like, could you, what do you mean by white paper?
So you know like how things have like blueprints and stuff. So in other CAD softwares like Onshape, you'll be able to transfer a sketch to sort of like a blueprint sort of you know thing.
Oh, I'm not sure about that. I've never.
Okay, I'll just search it up and like report.
So
Right.
here is so go to your Fusion 360. Yeah, in design, go to the design option. There you'll see yeah, so drawing. Yep, that's right, from design. And then you can choose the different views like top, side view and so on. And so you can choose, let's choose a push bot here, sample push bot. Choose a sample push bot maybe. Oh no, okay, no, sorry. Yeah, you can save it anywhere. Good. Save. No, okay, yeah. Okay, create, yeah. Okay, click okay. Oh,
It's
okay.
loading.
Oh, cancel. Okay, it's okay. It's loading that. So the only I think Onshape would have been also a good choice for us. It would have been little easier to get. The only problem is Fusion 360 has a better rendering, animation, all that. So and it's more powerful, but
Yeah.
it just
No,
takes.
it's because yeah, SCPS has been using Onshape, so we had to like switch over. But I've still been using Fusion 360. But yeah, one good thing about Onshape is that it has the nice, transfer your designs onto a blueprint.
Yeah.
Yeah.
This one has it as well. I mean, it's just
Yeah.
I think Ishan, your laptop is, I think a lot of stuff on the laptop or something. It just is.
Yeah, sorry about that. It's just,
Yeah.
yeah, I don't know why it's being slow. Okay, I think my software is about to crash. Yeah, this isn't loading.
Okay. Yeah, drawing is where you go to do the to create those drawings that you want to transfer. And then the other is you just want 3D rendering, then you go to the rendering menu and then render the object. And it allows you to set the lighting and so on. Ishan, what are you running the Fusion 360 on?
My Mac.
Okay.
Do you want me to show something?
No, I think. Let me see if I can show. And load it and show it to you. We are all in the same boat. I'm trying to load it on my laptop now. And, let's see.
Okay, I'm gonna switch with my other computer. It's open there. It should run. Okay, I'm gonna. Yeah, this is also slow. Everything's slow.
I think it'll kill all apps before you.
Okay, it's here now. I might wanna. I don't. I think this. If I try to create a blueprint from this, it's gonna crash again. This is really. Okay.
Okay. Let me share my screen. Okay, can you see my screen?
Yep.
So one is render. Okay. So go here. Let's see. So this is the push pod that I created. Okay, this is a sample push pod. So those who have built this, right, you can use this as a reference. And so now you render this. Now this is just a basic render, and if you really want it to render in a better quality, then you can click on this and it will render this, and then you can take a screenshot. Okay, so you can stop until it's excellent or final, right? As it renders. Okay, and then for drawing from design, yeah, so here then I can create a so I can say visible only. Let's see, create new. I don't remember how I did this, but okay. And so this is your side view. And then I think, say, for that, space view, projected view. Let's see if I remember what I'm trying to do here. parent view. So you can basically create new views out of this. And so there's a big view. Let me see if I can. Oh, it's here. Okay, got it. So projected view. Section view. Let's see what it does. So yeah, you can create those section views as well if needed. But so this is, I'll have to check, but this is one view. Then you can import the other views as well as you want to, this is the blueprint, right? And then I think it also creates bill of materials as well. Okay. Just try to figure out, yeah, how to add the other views. Is it here? Quick add. No, it's not. But yeah, so yeah, so then is okay. Let me save this first. Samples for drawing to save. Okay. I just got the base view here. The table can have other parts as well, right? So you can save the parts here, right? And it'll tell you what it has. Okay, so this is how you would include all the blueprints. But yeah, there is other ways to include different views of this part. Okay. The other thing that you have to, so there is a lot of precautions that you have to take when, let me get this back. So this is not drawing. Any questions? Any other questions? Anything that you want to see done?
I'm good.
Okay. So one of the main things that you have to, this is a lot about practice. Okay. There is, you have to start on a horizontal plane, right? Your parts, so that it becomes easier for as you import other parts, then they all line up properly, right? You don't have to then uh, so if you start with a part that is not completely horizontal or vertical, then if you want to line up, let's say I imported this channel and I rotated it to some weird angle, now everything else that I import has to now line up to that, right? So you have to make sure that you are careful about importing, and setting that plane, right, which is on XY. Start everything on XY, and then lining up all the other parts becomes easy. Okay. And then the other part of move and copy is that you don't use manual move and copy. So for example, let's see if I can show you something here. Okay. So if you want to move something here, right? So for example, let's say I want to move this channel onto um, onto this hole here, right? This one to line up to here, right? So if I select, so let's see, which one is it? Not this. I'm going to hide this one. Not this one, not this one. Which part is that? Okay, this is the part. Okay, so now I want to also make a copy of this and move it here, right? So what I did was I hit the other component here, right? So that I don't get distracted by that. And then this is very useful because it will save you a lot of time. Okay, so now what I did here was I said, okay, now I need to move this to line up to this hole here, right? So I would select point to point, okay? And then I would select, so I'll zoom in here and I'll select this point, okay, to this point here or this point here, this circle. So these holes should match, okay? And the other thing is I don't want to move them. I want to create a copy. Okay, so now I created a copy and then say, okay, so this is right. So this is not exactly correct because what I'd done was, see now it is now embedded inside the channel. I don't want that. Okay, so let me undo this and let me start over again. So this is what I want to move and move copy. So I have to be a little bit more careful on what point I'm selecting here. Okay, so I have to select the bottom part here, okay, because the bottom part is the one that is the hole is the one that I want to line up. Okay, what happened here? Select this and point to point. I want to select the origin, and the origin is this bottom portion, not the top. Okay, the bottom one, the bottom hole here, bottom side of that hole should line up with the top part here. Okay, and I want to create a copy. So now you see that now it's set up properly, right? So this is how you should look at moving parts or making a copy of these parts. Okay, and then I can enable this back here, right? Okay, so that's how you don't try to move something like, right? So you say move and copy, then don't try to move it manually, okay? Or like here, like free move, don't try to do that because that will all mess things up, okay? Always, because what you're trying to think about it when you're assembling the piece as well, you're trying to line up the holes, right? And that's how you assemble your CAD, yeah, these CAD pieces as well. Okay, the other part is you have to be, when you finish assembling this, right, you have to create a new component. Like for example, see these these parts belong to one. Now once they're assembled, they belong to one piece and then they move together. So that's why what we do is we try to create a new component. So here, this I should name this, if I can rename this somewhere. Can't rename it anymore. There's a way to rename it. No. Okay, so these are all part of one component. So then if I move this component, then everything moves together, right? For example, now this is also part of this component. So what I should be doing is I should be moving it inside this component here. Okay, so now, okay. So this was, so here, sorry, wrong place, I think. This one does not belong here. So I had to move it outside. Okay. So now this component has all these parts here. So that's how you compile them together as you build them, and then it becomes a lot easier to manage them. Okay. Anything else? So look at video tutorials, YouTube. There are a lot of and practice. Okay, you have to practice a lot to get to this, and you'll see it becomes easier and easier. So for all the new members who have finished their push pods, build your own, but don't build it here. Okay, what you want to be doing is, this is all parts that are going to be reused. Okay, so what you want to be doing is you want to go to absolute zero. You go on, parts is a is one of the projects, but you want to go to Fright Frenzy here, create your own folder here for yourself, okay? And then in that, create your drawing, okay? We will have then, a main robot, competition robot folder where we'll create the drawings for competition robots, okay? So the parts folder is for reusable parts. If you create a reusable part, then you can move it into this folder, okay? So for example, here, we have this push pod that I think you, I don't know, I think created in this. I think, what we can do is hopefully we can move this into Fright Frenzy, where we create a new folder here, and then move it there. Okay. So it's better to organize it that way so that this doesn't get too cluttered with other parts. Okay. I'm going to delete this as well. No. Anything else? Oh, one more thing. So these parts here, right? These are not exhaustive parts for Tetrix, though I tried to import as many I could. If you don't find a part, the way you have to look up is you have to look up the site. So for example, Go Builder, Actobotics parts, you may not have all the parts in here. Go to that site, look for the part, and then that part has a associated step file that you can download. You can download that and import it into this folder here. Okay, so for example, upload, right? And you can import it into this folder and then you use it in your drawing. Cool, so that's it from Seth. Any questions?
None for me.
Okay.
I have no questions either.
Okay.
Okay. Thanks for participating, everyone. Thanks for watching too.
No, thank you, Ishan, for the presentation and everything.
Yeah, and thanks, Coach, for helping out.
Well,
I had some technical difficulties.
no problem. Cool. This is good. Thank you. Okay. So let me.
Should we stay on this call for the WRO?
Okay. Yeah. So one sec. Before this, let me stop recording and stop this. Stay here. One sec. Okay. Okay.